Hello and welcome back. So let's take a look at question 4. This is again from the 2021 BC Calculus exam. Question number 4 is we're given this graph and it says let f be a continuous function defined on a closed interval -4 to 6. The graph consists of 4 line segments as shown above. And they're saying that g of x equal this integral right here. So again, this is our second FTC. Now I'm going to go make some rules right here. Well, if g of x is equal to this, I know that g prime of x would equal f of x, and that my second derivative for g is the slopes, or the derivative of f. That might help us out later on. Just get those out of the way. Part A, it says, on what open intervals is the function of g concave up? So remember, g being concave up deals with the second derivative for g. So that's our possible points of inflection that we have to find. So we want to find out where the second derivative of x is 0 or d and e. Now remember, we're looking at the second derivative. These are the slopes of f. So where's the slope of f? Undefined or 0. And of course we're going to get at -2. 4, there is a corner here, so the derivative is not defined there. So at 0, 4 is 1 and 2. Doing our sign chart, we're going to go from, of course, -4 to 6, g double prime and g, and my critical numbers here is -2, 0, and 2. Remember, we are looking at f prime, which is the slopes. So here the slope is positive, so that's telling us we're concave up. Slope is negative, that tells me g is concave down. Between 0 and 2, also negative, concave down, and from 2 to 6, positive is concave up. So we are concave up on the following domains. -4 to -2, it does say open, that's our bracket, that's our parentheses, or from 2 to 6, and that is because our second derivative of x on those domains is greater than 0. Pretty quick and easy to do. Nice little way to get a sign chart in there. Part B says let p be the function modeled by this product. Find p prime of 3. So of course we got to find the derivative. Let's go ahead and find p prime of x. This is going to be our product rule right here. So we take the first, g of x, times the derivative of the second, f prime of x, plus the second, f of x times g prime of x. So we got a lot going on here, so let's go ahead and find everything. First, let's go ahead and find g of 3. To get g of 3, we have to use our integral. 0 to 3 f of t dt. So that's our area. From 0 to 3. We want to find this area. There's 3. Now it's not so bad, not as bad as it looks, because a couple of things between the area between 0 and 1 and 2, those areas kind of cancel each other out. They're the same area. So I really only have to look at this, we really only have to look at the trapezoid right here. So it's this little piece right here. And that is going to be -1/2, the sum of the bases, 4 plus 3, and the height there is 1, so that's just -7/2. Okay, next we need f prime of 3. Well, that's the slope at 3, so f prime at 3, the slope here is 1. Next we need f of 3. Well, f of 3 is the value at 3, and it's -3. And next we need g prime of 3, which is also f of 3, right? Our rule g prime is f of 3, and that's also -3 right there. And I can just plug all those in. Therefore, I can say p prime of 3 is equal to g, which we said was -7/2, f prime of 3, which we said was 1, plus this is -3 times -3. And you can leave it like this, but if you simplify it, I believe you get 11/2 right there. You probably get a point for the product rule, maybe a point for, and a point, at least a point for the answer right there. I would think you probably get another point for finding the area as well. All right, let's take a look at part C. Oh no, it's a limit problem. You know, I'm thinking L'Hopital's. Let's see if this happens. So we want to find the limit as x approaches 2 of g of x over x squared minus 2x. So let's go and plug this in. Well, what is g of x equal to? It is the area from 0 to 0 to x of f of t dt over x squared minus 2x. Now the bottom, I already know that's going to be 0, but up here, remember I want the area from 0 to 2. So if I go here, oh, we already got that. Remember we said the area from 0 to 2 canceled each other out. That's just 0. So that area, this is that area right there, and it's 0. And we do get 0 over 0, and this is indeterminate. Therefore, by L'Hopital's, little hop in his talls, little L hop, by L'Hopital's we take the derivative. Remember, write this part out. Therefore, the limit as x approaches 2, the derivative, remember, is just f of x over 2x minus 2. And I'm going to go and rewrite this because remember what f of x is equal to. Oops, sorry. I keep doing it, sorry. Messed up. The derivative, sorry, was g prime of x. Got a little bit ahead of myself. That was g prime of x. And if I plug g prime of x, remember that g prime was f of x. I just got a little ahead of myself. 2x minus 2. This becomes f of 2 over, if I plug 2 in, 4 minus 2. And what is f of 2? If I go up here, f of 2 is negative 4. So we get negative 4 over 2, or negative 2. And there's our answer right there. You don't necessarily show all this work, but I showed every single step right there just to make sure we got it. But that's not a scratch out. Remember, that is just a 2. All right, part D. We're mathematicians. We love to part D. All right, so it says, first question says, find the average rate of change on G from negative 4 to 2. Does the mean value theorem guarantee that there will be a value for which that will equal? Justify your answer. So let's do the first part. Let's just find our average rate of change. Remember, if I'm trying to find the average rate of change, this is literally saying A rock, right? And that's going to be G of 2 minus G of negative 4, all over 2 minus a negative 4. On top, what are we going to wind up with? Well, G of 2, remember, is the area from 0 to 2, f of t dt minus. Now, take a look here. I would normally go from 0 to negative 4, but I don't like that, so I'm going to switch that around. I'm going to put my negative 4 on bottom and my 0 on top. See, my rule says go from 0 to negative 4, but if I switch them, all I have to do is make this a plus sign now, and we'll be okay. And this is going to become f of t dt over 6. There we go. Now, simplifying here, the top, this is just, we said is 0 from up top here for part C. 0 plus, and we want to find the area from negative 4 to 0. So we want to find the area from negative 4 to 0. And I've already done this, so we have a triangle here. Let's go and do this. This becomes 1/2. Its base is 2. The height is 6 to 0. And now I got this trapezoid plus 1/2. This is 6 plus 4. And its base is 2. And if you clean all of that up, we are going to get, what's that? This is 6 plus 10 right there, which is 16. So I know that this area right here now is 16 over 6. Whoops, that's a weird looking 6. Getting ahead of myself. And if you reduce that, you would get 8/3. Cool. The next part says, does the mean value theorem guarantee a value for which G prime is equal to the average rate of change? Okay, this is kind of tricky. So we got to think, what is, if we talk about the mean value theorem, remember what the rules are. 1, the function has to be continuous. 2. The function must be differentiable, right? And that's all we need. The function of g must be continuous, or g prime, in this case, must be continuous and differentiable. So let's see, is g prime continuous and differentiable? And the answer is yes. Because g prime exists, its function, because the derivative exists, the function must have been continuous and differentiable. And we can kind of say that. Since g prime of x equals f of x, we can say something like this. Because since g prime is equal to f of x, g of x is both differentiable and continuous. Therefore, the MVT, the mean value theorem, will guarantee that somewhere on that domain, -4 to 2, that g of x will equal 8/3, right there. Remember, and that's very simple, because g prime is the derivative of f, and it must be continuous, and g must be continuous and differentiable. Alright, hope you enjoyed the video. Go on to the next one. We'll see you guys later. Bye-bye.